So we are going to start with hooks in GitHub. So hooks has something which is to belong to and affect a specific repository and are not copied during a Git clone. So this is the peculiarity about hooks. In other words, hooks you set up in a private repository are not propagated to and do not alter the behavior of the new clone. If for some reason your development process mandates hooks in each coder's personal development repository, you need to arrange a copy of directory inside .hit, which has nothing but .git. We saw hooks, if you remember, in the previous chapter when we did .find. In that scenario, hooks are something which focuses on keeping some track of the files, which is like in context of your current local repository or in the context of the remote repository. So hook runs either in the current or in the local repository or in the context of the remote repository. For example, I say a scenario where you fetch a data into your repository from the remote repository and making a local commit can cause local hooks to run. Pushing changes to a remote repository can cause hooks in the remote repository to run. So in that scenario, hooks come into the previous thing. So Git has two types of the hooks, pre-hook and the post-hook. Pre-hook runs when the action completes. So you can use this kind of hook to approve, reject, or adjust any kind of the changes. Post-hook runs after the action has been complete. So this is done before an action has been completed. This is done after an action has been completed. And it can be used to trigger notifications or launch additional processing such as running or building or closing a bug. So as a general hook, if a pre-action hook exists with a non-zero status, the Git action is aborted. In contrast, the exit status of the post-action hook is generally ignored because it is done after the action has been completed. The hook can no longer affect the outcome or completion of the action. So at a first initial stage, a short brush up about the hooks. Hook changes the behavior of a Git. If a hook performs an unusual operation other than developers familiar with the Git may run into surprises when using your repository. A hook can slow operations that are otherwise fast. For example, developers can often entice to hook Git to run unit tests before anyone can commit, but this makes committing slow. A hook script that is buggy can interfere with your work or your productivity. And if it has some kind of the security reasons, like a malicious script could be easily smuggled into otherwise. So let's focus on the example of the hooks for now. Let's create a new hook by going to a bash script. So first of all, I'll clear whatever I've been done till now. Now I'll do mkdir. I'll create a directory. The name of the directory is hook test. Okay. Now I'll go inside that directory. Okay. And reinitialize the repository of Git. Or you can say initialize it. Now I'll do touch A, B, C. Three types of files are there. Empty files. That's why it is touch. Now I'll add this file, git add A, B, C. Check out for the status, git status. Okay, the new file is being added. Next is git commit -m added A, B, and C. The files have been added. Now what to do? Now we need to create a mode. So let's create, the create mode has been done over here for each of the files. Now I will do one thing. Inside, you need to put a following line inside this .hook folder. That is, first of all, find the hooks is present over here. So let's do find dot git hooks. Find, you need to specify dot first of all because it's a hidden directory. No such file or directory because nothing is present in it. So we'll create a script for now, and this particular script will be present in my pre-commit status. So I'll say, for example, I'll add a file echo. I'll add it like perfectly append it inside A. So if you view for A for file, it has this content perfectly fine. Yeah. Now I'll create another thing, echo broken B. Sorry, echo broken appended to B. Now do the visibility of that particular file, it's broken. Now you have made some changes in it. So you need to add this particular file and commit it. So let's do git commit -m test commit -a outside I'll see. So one file has been changed. Two files and two insertions has been done. Now I'll do again git commit -m test only file for example test only commit B. You see there is an unknown switch to B. This functionality says that there is nothing to commit, which is done with the help of hook. So observe that the commit works. So this is nothing like, it would be annoying to understand, like it's obvious like once committed we can't commit it again. So that is the major functionality of the scope of the hooks. That's what I wanted to focus in this chapter. So hooks functionality is nothing but to maintain the tracking of the commit in the proper manner.